Hey guys, a little bit of an update on the power supply. Let me just take the load off. I'm not going to share every single little detail with everyone because there are some secrets in here. This is a mock-up, a prototype. This will get made on proper printed circuit boards in a proper enclosure with a digital front end and go into production. So I'm not going to show all the little secrets. I can tell you now that there are parts in here that are way undercut for the job, that in the final production will be different parts, that small things from the transformer having more taps and more current rating and a core that saturates less easily and all sorts of little things like that to big things I'm not going to go into the details of. But what I will say is right now, the leakage current resistor that goes basically in between the wire that goes to the relay board to switch the taps and the sense wire for the positive rail. I usually have a 1 ohm resistor in between that to sense leakage current going to those two paths to deduct that from the current circuitry. That's how I maintain such insane accuracy on this amplifier for both the constant voltage and the constant current. At the moment, I'm actually having some problems with the constant voltage circuit. I actually had it down to the point where you could load it at 5 amps and it wouldn't move a millivolt. Now it's moving 2 millivolts. I know that's not a lot, and most power supplies do that, but for my specs, what I'm going for here is ridiculous transient response times, super low noise, and absolute accuracy. So obviously cramming all those three factors together into one supply is a little bit of a challenge, but I believe I can do it. So I'm just going to walk you through some of the updates because a lot's happened and I don't want to keep people out of the loop. I've labelled my front panel. Still missing panel meters. I've got them, just got to put them in. What else? Okay, so the switch mode power supply, which powers the voltage reference. Both of these boards have had heaps of components changed on them and values. If you actually look into the previous videos, you might be able to get a glimpse of them and see. The same thing for the driver board. It's looking quite empty right now. That 10 ohm resistor on there is just me trying to stick some offset into the emitter from the negative where it goes back to the filter cap, because what the problem is I'm having at the moment is basically on this remote sense resistor I'm not getting any voltage drop on it. With the link out using the remote sensing, but on the negative side with the link out trying to use remote sensing, I'm getting a voltage drop on that resistor down here, 10 ohm resistor, and that's causing me my 2 millivolt error. That goes to the emitter of the transistor that's acting as a comparator, so I've got to add some sort of offset. I did this in the design that I had on my bench. I just seemed to have forgotten to add it into this, and I noticed it when I was running the accuracy tests. Anyway, the thing we're here for now, I just wanted to show you the noise specs. Yes, that's around 50 microvolts RMS and a peak to peak about 480 to 560. So 50 volts RMS and 500 microvolts peak to peak. I am extremely happy with that. And under load, the microvolts only goes up in RMS to like 126 or something like that, and the peak to peak rises to like 700 microvolts. It's honestly nothing. The noise, I'm almost finished. I'm still trying to eliminate some of the peak-to-peak noise, but I'm almost finished. It's gotten to the point where, as I was telling someone the other day, my dad in fact, half the capacitors and shunt networks, or should I say snubber networks and stuff that I had in here to remove noise, after I got the noise levels down so low, they were actually bringing in noise from ground and common mode paths and making the circuit noisier, so then I had to go remove those. Just lots of little things. But anyway, this is where we're at the moment. I just want to show you, so no one thinks I'm bullshitting here about what I'm saying. So I put my positive lead right on where the output terminals are. You can see the two thick wires. You can see what's going on there. We're looking at the voltage. If we take our load bank, I've just got the remote sensing terminals just shut for the moment. I'm not using remote sensing. Right. 594. If I turn the load on, focus you. Fuck. Right. 5 amps. If we have a look, when I turn the light on, 2-3 millivolt drop. If I bump the voltage up a little bit, 2 millivolt drop, like I said. So, yeah, I mean, I'm trying to iron out where that loss is coming from. Oh, that's the other thing I wanted to show you. There you go on the scope with a 5 amp load on it. You can look at the trace of it off. I told you the transient response times are amazing. The reason you see the slope, the fast on time and the slope turning off is because I've currently got no loading resistor on the output caps. I'm actually changing that for a constant current source of 1 milliamp, so I can subtract that plus the error current from my current circuitry for even more accuracy. And I forgot what I was saying, guys. Oh, I don't edit my videos, so this is going to be annoying. There was one other thing that I really wanted to point out. Damn it. That is the way, isn't it? Let's see. I've taken some notes. I want to add also, I'm going to add some sort of a shunt network on the outputs. So when you turn the voltage down, you see that like sharp line when you turn it on as it transitions up. When you turn it off, it sort of goes down, then it comes back a bit. Well, that's going to be a sharp down line too. And the way I'm going to do that is by making basically a shunt network that when you turn the voltage down, it basically adds some resistance that's really low across the output. Well, not really low, it's in proportional to the voltage and how fast you're turning it down or where it's set at. It's kind of hard to explain, but basically what it allows the power supply to do is not only have fast transient response times on the going up part of the voltage, but on the falling side of the voltage. So that's where I am. The main thing that I wanted to point out was, like I said, noise. I mean, seriously guys, that's the noise floor with the power supply turned on. That's the noise floor with the power supply turned off. So Yeah, I think the quietest supply I've actually seen was made by a company called Power Designs back, I think it was 68. And it was either 100 or 160 microvolts RMS, I think. I'm trying to beat everyone's standards here, like I said. You know, all sorts of techniques of getting rid of noise, from shooting cables to just, yeah, I'm not going to give away all my secrets. Anyways, peace.